Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leave Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, 2017 questions on sequence and series. It was just part 4 or part B of a question, question 4, part B on paper 1. A square has sides of length 2 centimeters. The midpoints of the side of this square are joined to form another square. This process is continued. The first 3 squares in the process are shown below. Find the sum of the perimeters of the squares if this process is continued indefinitely. Give your answer in the form a plus b root c centimeters, where a, b and c are natural numbers. Okay, I underlined that word indefinitely because that is the biggest clue that it is a geometric sequence of some sort, and you are going to do the sum to infinity, okay, which is in your log tables here. Okay, so look out for that one. If it's some sort of a sequence and series questions, that is a good clue that it is a geometric sequence and you're going to be using the sum to infinity. To be able to set up that though, I need the first term and I need the common ratio. Okay, and the common ratio in English is what am I doing to move from one term to the other. Okay, so you need about 3 terms in your sequence to be able to do some maths on it. Okay, so even if you weren't sure about how to do it, once you see indefinitely, see can you get down the sum to infinity formula. You should be able to get the first term because you are doing perimeters. And if he's 2 and it's a square, then you know your first term, which we call T1, is 2 by 4, or 4 by 2, I should probably say. So it's equal to 8. Okay, so that's your first term for sure. My second term then is this inner square. Okay, so I need to get the length of one of these sides and it doesn't matter which one I get, okay? So how about we take this little triangle up the top, okay? So I know that's a length of side 1 because the squares are starting from the midpoints and he's a length 1, okay? So this is the Pythagoras theorem because that is the hypotenuse. A square has right angles. So c squared is equal to a squared plus b squared, okay? So for T2, I know that my c squared is equal to 1 squared plus 1 squared. C squared is equal to 1 and 1 is 2. So C is equal to the square root of 2. Okay, so that's one of the sides. So my second term then is equal to 4 times root 2, which is 4 root 2. Okay, so then let's have a look at my third term, and I'll have enough terms then. And to be honest, I have enough terms now, but anyway, let's get the third one. So what is the length of, if I take this triangle up the top, well, if he's root 2, then he's, how will I fit him in? This side here is root 2 over 2. Okay, so therefore then to work out my third term, it's again equal to c squared is equal to a squared plus b squared. It's equal to root 2 over 2 squared plus root 2 over 2 squared. Okay, don't worry your heads too much about it. Let your calculator do the work. Two squared by 2, and I'm getting 1 for that. So therefore c is equal to 1. Okay, so therefore my third term is 4 times 1, which is 4. Okay, so my sequence then is 8, 4 root 2, 4 dot dot dot. Okay, your common ratio is what did you do what did you do to go from one term to the end, okay? So it is equal to T3 over T2, or I could have done T2 over T1, okay? And that's what I meant by you had enough when you worked out 2 terms, okay? It's good to have 3 terms so that you can make sure that you get the same common ratio between the 2 of them, and then you know you've made no mistakes in coming up with your sequence in the first place, okay? So either of these will work. If I do T2 over T1, what does that end up in being? I'll put it into the calculator. I think it's root 2 over 2. Okay. Yeah. I'm going to do the other one because there's something I want to show you that could confuse you a little bit. Let me do T3 over T2, which is 4 over 4 root 2. Okay. It's T3 over T2. Okay. And you can see there straight away the 4's cancel and I get 1 over root 2. Now, this is 1 over root 2, and this is root 2 over 2. I remember I told you that the OR should be the same for them all. Well, they are actually the same number, okay? And I remember it taking me a while to get my head around them. It wasn't until somebody wrote this one out for me as surds. So this one here can be written as root 2, and then the 2 on the bottom can be written as root 2, because you know that root x by root x will give you x, okay? They're one of the rules of surds. And I've done a lecture on surds on YouTube if anyone is unsure, okay? So you can see that one of those root 2's cancels with one of those root 2's, and I do indeed get 1 over root 2. So it's just strange for some reason the Casio calculators writes the answers like this, which is a little bit unusual because this feels more normal. So either one of these for your OR would work. Okay, I'm just going to rub off here where I calculated the terms. They're all on the video anyway. Okay, and let's do our sum to infinity. So A, our first term, is 8 over 1 minus, and it doesn't matter if you put in 1 over root 2 or root 2 over 2. Okay, hit the fraction button, 8 over 1 minus 1 over root 2. And I am getting 16 plus 8 root 2. And it feels right because I've A plus B root C, and they're all natural numbers, so I got no negative numbers, so that feels right. The other thing I like is the fact that the question used 3 different letters, A, B, and C, which normally, not always, but normally implies that's 3 different numbers. Okay, 68 and 2, excuse me. So if my answer was something like 16 plus 16 root 2, generally they would ask you for it in the form A plus A root B. Okay, and that's the little hint then that they should be the same numbers. Okay, just one of those tiny little useful things in a question if you understand it. Okay, but anyway, for this question, that was the answer. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.